I want to be nice and hard. You know what we're going to do? Yeah? I think a few people have an idea what we're going to do. Alright, so, I want you to turn to whoever's next to you and talk about what you know about magnets. Alright? So quickly, what do you know about magnets?
They can only
Alright, you got 3 seconds. 2 seconds. 1, 45. And stop. Good. Alright. One group want to tell me what they know about magnets. This group at the back.
They can only attract to metal and steel.
Yeah, it's pretty good.
Iron.
Metal, steel, iron. Yep. So a few things. So hard, solid things. Yep. Magnets can stick to fridges. Good. And one more. Alicia, what you got?
Magnets are great.
Magnets are great because they pull things together and yeah, cool. Alright, I'm going to teach you something new about magnets that you didn't know, but I'm going to need Zane to look at me and have nothing in his hand.
Hurry up.
Good work. Alright, so what you guys don't know is that you see me in your class all the time, but I am actually finishing study. So I did school and then I went to university to become a teacher. Okay, so I want to become a teacher of a whole class. Alright, so you guys didn't know that, but this is me practicing to become a teacher. So, I'm going to teach you something about magnets. Can everyone see that?
Yeah.
Yep, no worries. Alright, does anyone want to read that for me? One person, Josh? Oh, Jason, sorry. Good, it's pretty close. The Earth, a magnetic field. Alright, so we know magnets can stick to, what was it we said? Steel, iron, and fridge. Fridge. Whiteboard. Good. Alright, I'm going to teach you something about how the Earth is a giant magnet. Okay? Whoa. Alright, this picture. You guys know what this is? That's the Earth. Alright, this is the north, and this is south. Okay? So we have north and south pole. Apparently you guys know that. Yep, good. That is good to know. Alright. Giant magnet, you say, Mr. Douglas? Yes. The Earth is a giant magnet. Okay, so I'll explain that. It means that inside the Earth, so I might, I'll get a globe quickly. So this is our Earth. It's plugged in.
Oh, no, it's just got a cord. Just keep pulling.
Cool. This is our Earth. We are in which country? Someone with a hand up? Everyone. Australia. Well done. And in Victoria. Good job. Alright, so this is our Earth. Now inside our Earth, because this is just the surface, but inside our Earth, there's lots of things. And one of those things is, there's iron. And someone mentioned it, Liam mentioned before, that we have iron that attracts magnets. Yeah? So there's iron in our Earth that acts like a magnet. It's like a giant magnet. Okay? Now this gives the Earth something called a magnetic field. Okay? Does anyone want to have a guess what a magnetic field is? Yep. Hard to explain. Alright, but
Can a
I'm gonna
person
explain it.
touching magnets put them down and leave them out of their hands, please?
Alright, so I have 2 magnets. Can you not be touching magnets? So, in my hand, I have, so that we'll use these ones. In my hand, I got 2 of these stick magnets. Okay? Now what happens is, both these magnets at the moment are letting out a magnetic field. Okay? So what that is, it's like radiating out here. It's a field. Okay? So, what I'm going to do is I'm going to test to see this magnetic field by putting the 2 magnets together. Alright? If the magnetic field really does exist, and I'm not a liar, then the magnet will stick to the other magnet. Okay? So, I'm going to put it,
Here, Jax. Yes. Sit down, please, Jax.
and look at sticks. Alright, so when I put them together, I can feel a force that's pulling them together. Okay, so about here, it wants to just come together. I'm resisting it. But there's a field that's pulling this magnet in. Now I'm going to let a couple of you have a go at this. So just want you to put it almost together but not together and feel how it's pulling it in. Okay, how the magnet is pulling the other magnet in. Alright, Rhiannon, I'll start with you. Okay, we'll just pass this around. Alright? So, what happens there is, obviously we've got a magnetic field on our Earth, okay? And things are pulled in. So, a magnetized needle, which I'm going to make in a minute, lines up with the Earth's magnetic field and it makes it like a compass. Alright, so when we have a needle or a compass, it points to two different directions. Does anyone know the directions?
Yeah.
Yep.
North and south.
North and south. Good boy.
It's
Alright.
giant.
So because the Earth is a giant what?
Magnet.
Giant magnet. Okay? It pulls to two directions. To north and to south. Alright? So I'm going to show you an example of how magnets pull to north and south. Alright? So you've still got your magnetic field coming around. Is that right? Yep, someone's got it.
It keeps clicking.
Okay, so I've got a magnet here. And I've got
Metal,
oh,
metal iron filings, yeah.
yeah, a bit of magnesium or
Iron filings, I
iron
think.
filings in here. Okay? So when I put this magnet in, from what I've told you, it should go to north and
South.
alright. Done before. Well, alright. So you can see that the iron filings are at this end, which we'll say is either north or south, and this end. Okay? So they stick to both the ends. They don't really stick in the middle, do they? Can you see that? Can you see? So it's cool. It's not sticking in the middle, but it's sticking to the north and south ends. Everyone see that? Yeah? So that's what happens with the Earth. Alright, because the Earth's a giant... The Earth's a giant what?
Magnet.
Magnet. Good, you're going to get this. The Earth's a giant magnet, and so this is what happens. We have a north and a south pole. Okay?
Well, you can tell
Cool.
him. Tell.
Alright.
Tell me go to Susan.
Magnetic fields. So I have started to explain that. So what is a magnetic field? I told you. It's the space around a magnet. And it's all this magnetic field, this force is coming off the magnet. Okay? You'll feel it as it comes around. So even if there's no magnet touching the other magnet, there's still a field. Okay? There's still a field. Alright. Let's show you a quick video. It should explain it a bit more.
Okay, now you're looking at a material that has all of the electrons lined up, and it is highly ferromagnetic. And it's called alnico, which describes the materials that make it up. And this material is so strong you can't believe it. Okay, now let's try to pull this apart. Let's see how strong it is.
So this is the magnetic field.
Well, that was pretty good, wasn't it? I actually pulled that apart. And let's see if we were going to pull this off. And let's see what happens. You see how strong that magnetic field is? Oh my goodness, look how strong that is. Uh-oh, now I got trouble. I'll bet I'm going to have a time here. Yeah, I got it apart again. It's pretty strong stuff. And you know what? The center of the earth is made of this material. It's actually made of this material. Why would God do that? Why would God make the earth out of something so strongly magnetic like this guy? Okay, now we got a little demonstration to show you why God made the earth with a magnetic field. That's the earth down there. Okay? And this is the earth's magnetic field. And this is the bad stuff from outer space. See, when the sun erupts, the sun sends all kinds of dangerous things to the earth.
Like,
Things that would kill
comets
us
and things like
if
that?
they got to us. Watch what happens as all this bad stuff comes to the Earth. Whoa, it didn't get there, did it? The magnetic field took that dangerous radiation from the sun and it sucked it away from the Earth. Let's try it again. No matter what direction the radiation comes from, the magnetic field of the Earth takes it and keeps it from hitting the Earth. We have a magnetic field to protect us.
Alright. Someone want to come and explain what he said at the front? You want to explain it, Zara? Can you stand up? Just explain one thing, what he said to us. Yeah, so it doesn't actually hit the Earth, does it? No, so all the radiation from the sun, so all the, what do you say, the bad stuff, that he said, doesn't actually hit the Earth, does it? Because the magnetic field... Good. And someone else, Cooper, you want to tell us something? You stand there, we'll look at you.
When it's a magnet because all the stuff would break on Earth.
Yeah.
Because it always magnet forces onto the magnet and not onto the Earth. And then the second thing comes up and sucks it up.
Okay, not bad, not bad. So did everyone get a go at the magnets? Did everyone feel that magnetic field?
And how? Just remember, Max 17. You've done that heaps of times in the last 4 weeks.
I haven't.
Untrue.
Cool. Alright. So,
Mr. Douglas, this has gone really flary for some reason.
that's okay.
Think you've got enough?
You can stop it.
Stop it.